Today we're going to do decomposition and decomposition and double replacement. So we've already done synthesis, single replacement, and combustion. And they're numbered 1, 3, and 5 on your foldable. And so today we're going to do decomposition, which is number 2. I like decomposition the best because it's organized. So it tells you exactly what the answers are. So this is all metal nonmetal, metal carbonate, metal hydroxide, metal chlorate, metal nitrate, and metal oxide. So all you have to do is look up what it is and see what the products are. All right, so we're going to look and do 2 examples. You'll see how easy they are. Your first example is magnesium hydroxide. So A, magnesium hydroxide, which is a solid, and it's going to decompose. So the first thing that we're going to do is we're going to label our metal, which is magnesium, and then this is hydroxide. And then I'm going to go to my foldable. And what I'm going to see is here is AOH. See, metal hydroxide. And that decomposes into metal oxide plus water. All right, super easy. Metal, magnesium, plus 2, right? That's the charge on the metal. Oxide, what's the charge on oxygen? -2, excellent. Crisscross, I get Mg2O2, I reduce. That gives me magnesium oxide. I look up my state of matter for that. Okay. Magnesium oxide is insoluble. So that's going to be a solid plus, let's see, what was the other one? Magnesium oxide plus water. Okay. H2O, and again, we're going to make it a liquid, and the reason is the chances of it getting up over 212 degrees Fahrenheit or 100 degrees Celsius, limited, so we'll leave it at liquid. And now I just need to balance. So I have 2 hydrogens here, 2 hydrogens here, 2 oxygens, 1, 2, and 1 magnesium, 1. That means I'm balanced, so I'm just going to write balanced here for you. All right? Super easy. B, strontium chlorate. And that is aqueous. So I'm going to go to my foldable, and I'm going to look up the chlorates. Here they are, AClO3, and it says that is going to result in metal chloride plus oxygen. Okay, so I look here, and my metal is strontium, and then I have ClO3. So I'm going to get strontium. What's the charge on strontium? Yeah, question. What is the charge on strontium? +2. Okay, and then chloride, charge on chloride? -1. Crisscross, and I get strontium chloride. This is a halogen, so it's going to be aqueous unless it's bonded to silver, lead, or mercury, which it's not. So this is going to be aqueous. Plus oxygen, because that's what it says. How do I know it's oxygen? It says right here. Chlorate is the chloride plus oxygen. That's how I know it's oxygen. And this is going to be a gas. And now I'm going to balance. So I have 6 oxygens, and here's 2, so I'm going to put a 3 here. 2 chlorides, and here's a 2 chlorides, and 1 strontium. So I am balanced. Okay? Any questions on decompositions? Yeah. A for metal, and then ClO3. So number 5, decomposition. Double replacement. Double replacement. For double replacement, you will need your solubility chart. Your solubility chart is found on the back here, right here, on the back. This is what you're going to use for your double replacement, all right? So the example that we're going to start with is sodium chloride, which is aqueous, because sodium is first family and there are no exceptions, plus silver nitrate, which is aqueous. And the reason is because nitrates are aqueous and there are no exceptions. All right, now, in a single replacement, it is an element and a compound, and the metals or the nonmetals switch places. In a double replacement, there are two compounds, and the sodium is positive, the chloride is negative, the silver is positive, and the nitrate is negative. So what's going to happen is these two are going to switch places, and you're going to end up with two completely new compounds. All right? In a single replacement, you end up with one new compound, but in a double replacement, you end up with two new compounds. Now, in a double replacement, two criteria must occur. Must be met. They are as follows. 1, both reactants must be soluble. So they have to both be aqueous, and I'm going to explain why in a minute. And number 2, one product must be either a solid, a liquid, or a gas. Now, the reason that one of the products must be a solid, a liquid, or a gas is because, as we saw earlier, maybe we didn't. Maybe it's in the period 2. I'm going to show you. But in an aqueous compound, when you put it into water, it breaks up into ions. Okay? And that's not a compound. So it didn't come together to actually make something. All right? And so what we need is for it to come together and make something. It's called a precipitate. It needs to come together and make something. And we're going to talk more about this on Monday, because I'm just trying to get in what this is, the five types. And then on Monday, we're going to talk about all the vocab words. All right? So solids and liquids, that's easy. We get that because we have our chart, right? But gases are a little bit more challenging because we don't really have gases. So here are some of the possible gases that you might see. H2S, carbon dioxide, nitrogen monoxide, sulfur dioxide, hydrogen cyanide, or a metal oxide. So as long as that criteria is met, that both reactants are aqueous, and that would mean that all 4 ions are floating around and able to react with each other. And as long as 2 ions come together and make some sort of a solid or a liquid or a gas, then the reaction will go. So in this reaction, all right, these two are going to switch places. So we're going to end up with sodium +1 and nitrate -1. So we're going to end up with sodium nitrate. All right? So we're going to end up with sodium nitrate, which we know is aqueous because of the sodium and the nitrate. And we're going to end up with silver chloride. Silver is +1, chloride is -1. And we know that this actually is a solid. And you know how we know? Because the chloride, the silver is the exception to the halogens. So this actually will go. Now, if the reaction doesn't go because these two do not, because these two criteria are not met, then you write no reaction and you just move on. All right? Don't waste time trying to finish it. The minute that you see, oh, one of the reactants is not aqueous, just write no reaction. The minute you see, oh, one of the products isn't a solid, a liquid, or a gas, just move on, write no reaction, and move on. Okay? Got it? So both criteria are not met. You have to meet both criteria, okay?